Yo, today I was thinking we're going to take a look at debouncing. I'm going to show you an example of where we can use it, and I'm also going to talk a little bit of why we want to use it, and then also finally, of course, I'm going to show you how we can implement it in our application. So I have a really basic example here on the right. It's an application that fetches some users. Right now we're fetching 10 users. And then we have this search input over here, so we can search for names of users. Now currently our application is really basic, it doesn't have any debouncing or anything. So let's take a look at what happens, and I want you to pay attention to the networks tab down here. So if I want to search for Liana, I can do that. But as you can see, every time I hit a key on my keyboard, we're going to send a new network request. So we're going to send a network request with search L, and then we're going to get a response every user that has an L in their name. Then we're going to send a second network request with LE, and get a response every user that has LE in their name. Now we're going to do this for every letter in her name. And this is really bad because this creates a lot of network requests to your server, and your server has to handle all these network requests, which is a little bit redundant because at the end of the day you just want to search for Liana. And this is where debouncing comes in. The debouncing is a technique where instead of sending a search or doing something every time the user presses a keyword or something like that, we delay a little bit and then wait and see if they are finished, and then only when we think they are finished, that's when we actually send the request. So how can we achieve this in the code? Well, first let's look at what we have currently. We have a state for the search, which is just mapped to our input. Then we have a state for our data, which is storing the users that we want to display on the screen. Then we have this use effect, which triggers whenever the search changes, and this is going to fetch the users. This is simply a fetch request that just checks if the user has typed in any search. We're going to add a search param, and then we're sending a fetch request to our backend API users, and then we're appending this search at the end. This is the search we see here in the network tab. And then when we get the response, we're just setting the data so we can render it to the screen. Now, how can we introduce debounce to this? Well, I have created a debounce hook, which is really easy to create. This is something you can just copy into your code, but let's take a look at how it works. It takes in a value, which could be whatever type you want. In my case, it's going to be a string. And then we're setting a delay. I'm going to default it to 500. And what this does is we are creating a new state here with the debounce value, and we're setting it to the state that we're passing in. And then we have this use effect that checks whenever the value changes, the value that we pass in, or the delay changes, we're going to set a timer, and this timer is going to have the delay of whatever delay we're passing in. And then when this delay has finished, so in our case 500 milliseconds has passed, we're going to update this debounce value and set it to the value that changed. And then finally we return a clear timeout from our use effect. Is basically seen whenever this use debounce dismounts, we're going to clear our timeout so we don't have any dangling timeouts whenever we navigate to a page that doesn't use this, for example. And we simply return the debounce value. So how can we use this in our code? Well, we can just come here and create a new debounce search. We're going to pass in the search, and actually I'm not going to pass in a value here because it's default to 500. Now of course you can set this to whatever you want. You can set it to 300, 1000, whatever. It depends on how long you want to wait before the user stops pressing their key until the action is actually performed. Now the reason why we want to have a separate thing for this and not maybe change this to like a use debounce state is because we still want this input to be really reactive. So we want this input to reflect whatever the user types as soon as they typed it. We just want to not send the network request. So now that we have this debounce search, we can, instead of listening for the search in the use effect, we can listen for the debounce search, and then we can pass in the debounce search as well. So if I'm going to clear the network tab now, and you can see that whenever I type Liana, it's only going to send one request. So basically what it does is that since I'm typing faster than one letter per 500 milliseconds, it's going to wait until I've typed the last letter, and then it's going to wait another 500 milliseconds, and then when nothing happens for 500 milliseconds, then it's going to execute the query. And this is a lot better because now we only search for the thing we actually care about, and we're reducing the number of requests we're sending to the server. Now we can actually take this a step even further, because if I clear it in the network tab now and I refresh, we're going to see we're fetching the users. Now we're fetching it twice here because this is how React works. When you run React in developer, it's going to fetch twice. but when you build and run in production, it's only going to fetch once. But we're fetching all the users and we're rendering them to the screen. If I type Liana now, we're only going to get Liana, so this is really good. But if I go back and I want to see all the users, we're fetching the users again. Now we don't have to do this, we already fetched the users up here. So we can just use this data, we don't have to send a new request to the server. So to take this a step even further, we can use Tanstack Query. Now I would highly recommend you to use Tanstack Query anyways. Doing it this way could lead to a lot of bugs, where if you don't use the use effect correctly, it could re-render a lot of times. And also you probably want to handle error states and loading states and stuff like that. So I will highly recommend you to use Tanstack Query anyways, but for this case we're going to see how we can use it to cache our data. So I'm going to comment out all of these things. I'm going to create a query, which is going to be a use query. We're going to pass in a query key, and I'm going to pass in both a key for like what this is fetching, so users, and I'm also going to pass in the search. Then we're going to have a query function, which is going to call this fetch users, which is the same function down here, with the debounce. Now, instead of setting the data manually here, I'm just going to return the users. And then down here, when we render, I'm going to check if the query is pending, like so. And we're going to do a query. So if the query is pending, or if the query is not pending, we're going to render the data, but if it is pending, we're going to render loading. So let's see what happens now. If I clear the network, refresh, we're going to fetch the users. If I search for Liana, we're going to see we're only searching for one. So this is the debounce effect. This has nothing to do with Tanstack. This is debouncing. And then when I go back, we can see, wait a second, so we're still fetching the users, even though we still have it there. I thought Tanstack Query was going to catch this. Well, the problem is that we have to do one additional thing. We're going to have to specify a stale time. Now I'm going to set this to 5 minutes. And this is basically saying that, okay, when you fetch this data is going to be correct until 5 minutes have passed. So you don't expect it to change for 5 minutes. So you can just use the same data. Now you can set it to whatever you want. You can also set a GC time or GC time to whatever you want. And this is basically, as it says here, time in milliseconds that unused or inactive cache data remains in memory. So Tanstack has a garbage collector which is going to clear inactive data. But if you set this to, as I have here, 10 minutes, then it's not going to clear inactive data before 10 minutes has passed. Now you can do whatever you want to do with this. The most important thing is this stale time. So now, if I clear the tab and I refresh, we search for users. I can search for Liana, and we search for it. We send a network request because we don't have it in our cache yet. We get the response. If I clear it, we can see we don't send any request for the users because Tanstack Query is going to check the cache for users, and then in this case no search, which is the same as this one, so it's just going to reuse this data. Now if you search for Liana again, then it's not going to send a new request here either. It's going to use the data from this one because the query key is users and then this debounce key is Liana. It's going to check the cache. It's going to check that, oh wait, we actually have the data for this. But if I go back and I search for Irvin, for example, we haven't searched for that yet. We haven't used that query key yet. So it's going to go check the cache. It's going to see that there's nothing there. So if I type Irvin, we're going to send a new request for it. And then we get the data. One thing I want to mention is that in this case I have set the stale time and GC time here in this local query. Now if you want to have the same policies throughout your application, you can do so by going to where you define your query client. When you use Tanstack start, it's going to be in your router. And then here we have the client. Now if you use these default options, queries, you will have the same like stale time and GC time, and you can set this to whatever values you want. This is going to be your global values that all your query is going to default to. Now if you want to overwrite them, you can always do it like this and use these values instead, but then you at least have some fallback values here if you don't want to define them in every single query in your application. If you want to check out the code, I'm going to leave a link to it in the description, and if you have any feedback or any questions, please leave a comment, and I will see you all later. Bye bye.